exist anymore. And he should actually also still cancel, accept my friendship request. So let's just say that he's not like actually active anymore. But as you can see, we can find a lot of information about him, not only who his friends are, but also where he worked, other platforms that he uses, friends that he is engaging with, and even similar people that have the same pattern in their life, which makes them a people that I might also know, a person. But what he doesn't know is that Facebook tracks way more than that. For instance, recently he's been to Ireland, and when he landed in Dublin, he spent there a few days and then went to Waterford. And one of his days he left to Belfast, and he might have forgotten about many places that he visited, but Facebook still holds all that data and all that information. And when he was there, he had to work a little bit, so he shared some files and he shared some pictures with his friends. In fact, even his email correspondence and his messages that he uses via Facebook Messenger and his pictures from partying, they're all in hands of big databases from Facebook. And the risk with this is that also if he looks at new people, people that he meets there, people that he has been there with or that he would like to connect with just in general, it's all known to a huge giant organization. And that might make it a little scary because when he goes to the gym, there's a track record of when he is there, what he does there, who else is there, who he might be joining with. And even if he attends any events like going out, going to a club, visiting a DJ or church house, it is known to Facebook. And we must actually start wondering, is it fair that one company has all this information? Because based upon this, he has been getting more and more advertisements, for instance, for flying. And he has been getting more advertisements for going to clubs. And they figured out that if he goes on Friday to a club, that afterwards he would like to get a pizza. So he is seeing that on the weekends, more advertisements for fast food. All consequences in the e-commerce market where some players can very much benefit from, where others don't really have the access. And that brings to the next example, TikTok. Huge competitor from Instagram, and even Instagram's stock with Facebook stock has dropped drastically a couple of months ago because of the increase in growth from TikTok over the world. It is known that TikTok is not only a platform used for just watching some videos, but it has a completely different marketing strategy than Facebook itself. Because Facebook has this passive idea that if somebody goes somewhere and I would like to go there too, then I will see probably the same advertisements as what my friends have seen. And that is still programmable in a decent amount of codes. But TikTok uses way more advanced learning. So for instance, if I like particular elements in a video like a guy using furniture for drums, then it might be that the next video has the same kind of images, pots, pans, beer pong cups, or a man with dreadlocks, as the next video. It even listens to the music that it uses, and it sees more and more from the images as a part that it can base upon whether or not you would like to buy a particular product. And in fact, that is what happens. These TikTok advertisements are used more and more for advertising products. And that's where the e-commerce comes into TikTok. If this person would be selling kitchen furniture or party cups, then it could very well be that this person right now has some affiliate going on, or that people see this video and might think, wow, I would like to have the same kind of furniture because that is apparently not only pretty furniture, but also furniture I can make music with and record cool videos with. Maybe there is something in there that I would like to have too. And that is no longer the classical way of marketing where I would be bombed on Facebook with advertisements or bombed on the highway with road signs, those huge billboards. But this is me going to a platform to look for advertisements. And these advertisements are good because, for example, this lamp, the famous TikTok lamp, it is a product that has been growing over the years with the increase of the platform TikTok itself. It's known for, if you have a TikTok platform, if you have an account on TikTok, then you would probably need one of those lamps because you would like to record yourself. The idea is that it highlights your face and it makes you look very good on the camera. But the thought behind it is that this lamp somewhere sells between 8 and 60 euros. And there are being sold at this moment as we speak about 1,300 per month in the United States. That is a revenue somewhere between the 10 and the 70,000. And that is solely thanks to TikTok. In this graph, you can see that the TikTok platform has been drastically increasing over the years since 2018, and that in the year 2020, the beginning, we saw actually a pretty spiking increase due to, of course, that we were all locked at home. And after that, we saw that this trend actually continued, and so did the TikTok lamp. These two correlate very well. And that means that if you can find these patterns between events that happen, platforms that arise, and the moment where you need to jump into a product to start selling it, that there's a lot of data in there that we could use. And there's one company that is by far the best at that. And that is our yellow giant from America, Amazon, known for its three-folded layers of selling. You can either be an FBA, an FBM, or an Amazon itself seller. The FBAs are fulfillment by Amazon, and that means that these third-party sellers are allowed to sell on the platform, and the customer might be thinking, hey, I'm buying from Amazon, but in fact, it might be any other person that is just selling on the platform as an Amazon fulfillment delivery. So what happens then, the products are bought anywhere from a wholesaler, shipped to an Amazon warehouse, and from the Amazon warehouse, it will go to the customer. The FBAer, as they are called, doesn't even see the product often, and Amazon gets its commissions based upon the investments that the FBAer makes. Then there's FBM, fulfillment by the merchant, where the merchant itself will try to find products on the market that it can be selling on Amazon, and then Amazon gets only its commission, but the merchant will still do the fulfillment. And lastly, there's Amazon itself, the Amazon basic products. And we all know the creepy stories about Amazon looking into the niches, finding those products that are being sold best by FBAers and FBMers, and taking over the entire listing. These stories are rumors, they can't be true. But what is true is the asymmetric symmetry of data, because Amazon is the owner of the platform. And that means that if Amazon sees that a particular product is selling very well, then it's in their database, and they could analyze the database based on their over 300 million different products. They can see, well, today the PlayStation 5 is new and that one is trending. We need to have PlayStation 5s. They could buy a whole bunch. They have the budget, the resources, they have the connections, and they could start selling this product too. But that would kind of cut out the FBAers and the FBMers from the market. Amazon has access to data that all the other parties don't have. And that makes it a very interesting situation, because that is, for Amazon, a huge advantage. It can see what the FBAers and the FBMers are selling, but it's not vice versa. So it's not transparent. It is not very fair. And it is actually a little bit of data intrusion. You might want to see that these companies that are FBAer would like to have this data too, but it doesn't exist. So the big question that we'll be answering today is, how can we make sure that those merchants get their share of big data? And we are here today with a lot of programmers, so there's a lot of skills involved. And I'm going to try to keep it not too much into the coding part, but really into the how can we commercialize all this input of information into something that anybody understands, and that basically can make the decision, you should be buying this product in order to sell it, or this is not a good investment. And if we can define this, then we can empower all of these merchants with the same strength of data as that Amazon has itself, and that would make the competition a little bit more fair. A little bit of background information. Who is this guy? Today, for the first time in a talk with Codelabs Academy, my name is Bart. I'm 23 years old, and I'm an international business student from Maastricht University. I've recently graduated. It means I'm waiting for my diploma, but COVID is kind of in between still. And I will continue this summer my studies at Harvard as well as at Richmond. I've been entrepreneurial since I was a kid, and I've had e-commerce businesses on both Amazon and bol.com. Bol.com is a competitor from Amazon in the Netherlands. It's very hard for Amazon to get the market, take it over the market share from Amazon, from bol.com, because bol.com is very nationalistic in its support from the inhabitants from the Netherlands. I did some good sales, and with that I started an organization called E-pickr, and E-pickr's goal is to empower every merchant in any platform, and there are over 350 different sellers platforms like Amazon and like bol.com with the right set of data. And in order to do that, we once started our journey a long, long way back with scraping data. It was the very, very, very basic method of go to an Amazon page, look for the listings, copy their prices, copy their titles, images, amount of reviews, and see if we can somehow formulate this into a very interesting database and be able to sell that. This was very time consuming and it was very difficult. As I once wrote in an article about reliable product research, it's all about finding the right set of data, and that data is out there, but we need to know where to find it and what exactly to scrape. And Amazon, for instance, does not tell which products you can sell best. It has a bestseller product for the customer, but we don't know what we should be selling as an e-commercer. And the biggest difference between Amazon and bol.com in that regard is that if we would look through the platform from bol.com and scrape the right numbers, then we would be able to find exactly the inventory from other sellers. And that is very interesting because, for instance, the Philips 8000 series vacuum cleaner has currently only 4 units in stock. And if tomorrow that number changes from 4 to 3, then we know that there has been one vacuum cleaner being sold. As well as that, we see that the hard stopper volume, we try to put 500 products in the grocery cart, and I could only return 393. That means that the maximum inventory right now is 393. And if we would be able to write a proper set of code, and I've done that in a little bit of Python script, you go to the bol.com website, you look up where you can find the products, you copy their European article number, you put that one in your grocery cart, you increase the amount to 1,000 or 500, and then it will return to you the actual value that is in the grocery cart available. The output will be deposited in an Excel sheet, and the Excel sheet can track over time how many products there are each day in inventory. And if on day 1 we have 130 products and on day 2 125, then the amount of sales on day 1 must have been 5. It is an assumption-based algorithm, and it's only one, it's a lot of lines of code, but it's only one data point that we're gathering with this. So it's a little bit slow, and we should actually find a method how we can make this more efficient. And that is what scraping brings for issues in this search, in this quest for all these platforms out there, for all these services that we try to create. There is a ton of websites, a lot of information that we can scrape from them, but it is very time consuming to make each line of code. As you saw, it was an entire page of coding just to get one simple input from a website. And if we would continue doing this and the website would change its own website, then we can no longer scrape that information. And what if the information that we have scraped sometime become outdated because it's 5 years ago and that product is no longer relevant, or there's a better product or a newer website? That makes this a very tricky method, and it's actually very roughly scalable. But luckily for us, there are other systems, and that is one of the most used systems nowadays in the product research market. It is connections with APIs. There have been a lot of scrapers that created databases, and there are even Amazon Web Services that provide databases for a large sum of money, where you can just instantaneously track products over years, find products from back in the days. And that is a huge outcome, because that means that if we have the right set of data available and we know what to do with the data, then that means that we can actually kind of simulate the same kind of information that Amazon itself has. And thank God for that. It's namely a little bit like a kitchen. What you could see is each website has a server, and the server could be regarded as a restaurant. And in the restaurant, we have our customers that come there to dine or that need the data, and we have our ingredients. And those ingredients can be seen as the data. And if that is the right metaphor, then the equipment in the kitchen, the pots, the pans, the stove, and even the oven, they might be our algorithms to find this exact set of data that we need. And then to top it off, the guests are the users, and Amazon might as well be the boss of the restaurant because they can see both the ingredients and what the users want to eat. He walks to the restaurant to see everything. And then our APIs, I would say they are the cooks because the API is the one that transfers the ingredients to the pan and from the pan to the plate. And that is everything that the kitchen actually needs, the right set of APIs. But where does the cooking start then? For instance, we know if we would start baking pancakes right now and we would bake 100 pancakes, that probably one of them will succeed. But that is a lot of trial and error. And we know that we have right now found a method to use huge databases through APIs. How do you know what information we need in order to define a good selling product? And how can we now fill that gap for the merchants with the data and the input, the knowledge that they need? Well, it begins with trial and error. That is where we once started, and it was a lot of learning and a lot of information that we got was actually not relevant. Um, each set of data holds valuable input, and each set of data holds less valuable input. And if we would have continued this way, there would have been probably after 300 products a bunch of succeeding ones and a bunch of not so succeeding ones. But it would take us years and years to find the right ones to make a portfolio of only good selling products to actually make a good profit on Amazon. So what we did is we did some market research. We looked for 300 products by hand, and we started tracking all kind of inputs for data. For instance, not only the price and the title of the listing, but also what is the image size and how many images does this person upload? And if the seller uses 600 words to describe the product, does it then convert more often? Or if we use 700 words, is that better? Where is the tipping point for a customer that he stops reading? And how many reviews do you need to have to look credible? And should those reviews always be positive, or does that make it less credible? There were so many variables that we analyzed that in the end, we started making a table, and that table wasn't very organized. So yeah, after 9,000 entries and a lot of unorganized headings, we decided, well, let us first look at the whole database. And we started with yeah, real developers that actually understood what they were doing. We were still students in that time. And we asked them, can you do the same thing as what we have done for 300 products, but then for 300,000 products? We want to see the big data. We want to see every form of pattern that there was. And after filtering out a lot of scrap, we actually saw that there were patterns arising. Things like, well, if there's a lot of reviews, then there's also a lot of sales. And if the sales increase, the reviews increase quicker. And if we see that, for instance, the price drops, then we see that there's more sales. But is it always a good point? Because that decreases your profit. And in that way, we formulated tons and tons and tons of algorithms that at some point created a very nice database. The database itself is by now so large that we don't use Excel anymore. And we store everything that we have attracted via the API in our own data warehouse, just to always have access to it, also in the future. But then the most interesting part is if those patterns are so clear, does that then mean that there's an absolute truth to the input that we need to give the right data to our merchants? And actually, 99.18%, yes, that was the case. In some products, you could really see if this product is, for instance, blue in color, has a price of $15 and is sold on the American market with 5,000 reviews, then the amount of sales will be pretty much predictable. And it was a lot of work. It was a lot of figuring out. And in total, we discovered about hundreds of those lines of assumptions that if they hold, then you come up with a product that might be selling well. And that's where we decided, well, but now we've done all this work by hand. Isn't there a smarter way that we can deal with this? So for instance, what if we would write an algorithm that could do this work for us? And actually, that came pretty close to a very famous theoretical piece of academics. It's namely when you gather your information and you standardize the data set, you can build a model around it. You can have some customer feedback and optimize the model towards that it's actually matching with reality. And then you can deploy the model on new data. And here we see that we're actually starting to mine data. It is the topic that I chose for my thesis. And if you have the right understanding of the business. So sales means profit, a high price means higher profit, but higher price means also less sales. Then you can start understanding which inputs for the data you need in order to make a complete model that you can, after a couple times evaluating, deploy on a new set of data and let it learn from the new set of data. And that is what we try to do, an algorithm that could recognize success. And with the success, we mean a successful product. But if the successful product is already defined in a particular set of variables, then it means that the only thing that the algorithm should be able to do is do exactly what the human brain can do. The enough input will create an output. And that is where AI and this big data, pretty big umbrella terms, become suddenly very tangible and become very realistic. Because if we can do it in our head, then the only thing we need is a super brain to do all this work for us. Because right now we can analyze one product at the same time, and that is an interesting amount of information that we have. But if we would like to make more judgments, 300,000 products at the same time, then we need to have more brain capacity. And this brain is big, but it's not big enough for 300,000 products at once. So if we would look at the AI system that we've developed throughout right now with the inputs from the API, where we can find all the data that we need, ranging from the amount of spaces between the words, the amount of characters in a title, the amount of reviews, and even the amount of pixels in an image on an Amazon listing, then from all this information, we can build our own cells. We can see every dendrite as a input point for data. And if we give our cell body the right lines of code, then it can create an output via the synapse that is actually very similar to an AI system. And the only thing that we then have to do is make sure that the rules are there. We need to define the boundaries. We need to make a right set of judgments. For instance, there cannot be a rule being developed that at some point the color blue will always be regarded as a successful product, or the color red is always associated with negativity. There need to be actually great input data points from the dendrites, and the cell body needs to be able to filter them. But an AI system is already capable of doing that, because an AI system is in the essence nothing more than what we have already discussed as a super brain. If we give it the right set of variables, for instance, let this left neuron be the one for defining the amount of sales of products. For instance, X1 could be the amount of reviews. X2 could be the ranking of the reviews. X3 could be how many times the word good or super pops up. And the amount of negative keywords, for instance, bad or broken, could be X5. Then we have a complete set of input that we can put through our cell body, our formula, to create a particular output, for instance, a number of sales. And that output can be the input for the new cell. So if we have the number of sales, and we also know that X1 is the price, and X2 would be our cost of acquisition, and X3 would be the commissions to Amazon, and X4 would be the shipment costs for getting the products from the factory to our own warehouse. Then we can start defining in GX what our profit would be. And the output is then literally whether or not we're making a profit. And this is a very simple representation of that. But in essence, that is exactly what happens right now in those advanced systems. And that's exactly the data that Amazon has as well. A lot of input from where does your cursor stay the longest on the landing page? Where does your eye look the first moment if you look up an Amazon listing? Do images with a white background work better? All of these variables can be put into the system. We're talking about big data systems, huge amounts of information that can be processed all at once. And what you will then get is that every single piece of information can be used in different kind of correlations. And not every correlation will be useful, but the consequence is that every piece of information can be regarded as significant or not. And if it's significant, then it continues to the next synapse. And if it does not get over the significance value, then you could drop it, because that is exactly what our brain does as well. And next to fx and gx, we can also continue with making more and more of these formulas. And by expanding the amount of formulas, we will automatically expand the amount of possibilities of output. And if we then have all this information that started with something as simple as the amount of pixels in an image, and we would end up with the amount of sales of a particular product, then we're discussing big data. And that is what equals us to the information that Amazon has as well. And then you can start making a proper business decision whether or not to sell a particular product. So if you would look at E-pickr in the website, we look for the TikTok lamp, and we will find that the lamp indeed sells 1,305 products, and that the listing strength is indeed very high because this product has the colors that attract the eye. And in there, the camera, everybody knows that if you start talking about TikTok lamps, you would like to associate it with social media, and social media is very well high in demand. So you can see that from every angle, there is a right amount of data that is really brought back down to 4 or 5 pillars: higher demand, competitor check, financial fit, and the revenue potential to see whether or not this product is actually profitable. And that equals you suddenly to Amazon business itself. And what we did next to that is not only display the information of today or this minute, but also what happened 5 days ago or 10 days ago. We can build a complete platform with all these kind of tools that exactly define what you need to know in order to make the right business decision. I had never heard of these gel ball blasters, but until somebody mentioned to me, like, hey, have you seen this TikTok? I looked up the TikTok video. I saw this product. I instantly thought, what an awesome product. I started looking into the data behind this product. And I saw, wow, there are actually being a lot of sales made with this product. Some of them had only 3 months ago almost 4 to about none sales per month. And right now they're already 2,500 sales per month up. You can really start to find patterns that are more and more powerful, and that only with the right input. And then the question is, where does this information lead us? Because we saw in the beginning, we have the FBAers, the FBMers, and we have Amazon itself. And Amazon has access to FBA and FBM data, but they don't have that access back. But if we can simulate the same type of data and start analyzing it through and through with the amount of big data that is available out there, and we have seen on Facebook and TikTok pages how much information there is out there. If we can find these correlations and we can find these patterns, then we can actually simulate exactly what Amazon knows, but then not from the uh, true source, because Amazon doesn't give the information away, but from the actual people source. And that is what we have done with E-pickr, and that is what we will keep on doing. And I hope that you, as the developers, really like to see that there's so much potential behind data, and that although that it starts from a very simple scraper that has nothing to do with big data yet, that you can formulate the right set of variables, and that the set of variables will grow and grow over time. And in the meantime, you will see that then all of this information will lead to a proper business decision. A very funny anecdote that I always like to share is the one from a little guy, 16 years old, didn't want to work as a mail deliverer or in the grocery shop as like fulfillment. He said, you know what, I'm going to start my own e-commerce business. And his dad said, yeah, sure, go ahead. And his information was basically, I need to buy a product somewhere far away, then I ship it to the Netherlands. From there, I can sell it for a higher price. And there we go. And with a little bit of help, we could explain to him that there's a bit more behind e-commerce than just that. And then we asked him, like, which product are you going to sell? And he started looking and looking and found eventually a product, sushi kits. And currently, the little kid's earning more than enough money with these little sushi kits. And it's very interesting to see that he actually managed to identify a product with the use of the tools from E-pickr to make a good profit by himself. It's all about knowing that there's power in data. And I think that everybody at Code Labs Academy will agree to that, that there is a huge amount of power in data, and that all the people that follow this talk today, your developers, I've seen front-end developers I've seen several type of people joining today that I thought, well, that might be somebody that actually really would like to work with this set of data. Let us then share the data and let it be a powerful lesson that everybody can build a database this big and even compete with Amazon, because they're big, but we're smarter. Thank you very much for listening today, and I hope you enjoyed it.
Thank you so much, Bart. That was very interesting, even to a not non-tech person like me. There were some questions in the chat if you would want to have a look.
Yes,
And yes, actually mentioning Amazon, so exactly what you were talking about.
I will
Yes, so
scroll back up and then see from the beginning, go over the questions.
thank you so much, everybody, for joining us. Uh, please check out E-pickr and please have most of luck of your own web development or e-commerce journeys, and let us know how you like the event. You can check out the whole thing later on YouTube, and but I'm sure Bart will answer any questions you have.
Thanks very much for everyone for joining today. Thanks for all the thank you. So really happy that I saw Selenium, Tom Tavernier. Would you?
Yes, I saw your first script was kind of Selenium scraping script. It was
Yeah,
kind of a Selenium thing, I think. So yeah.
it's very fun. Like I had zero coding experience, and there were a few people around me that said, "Can I help you with that?" And we literally started by defining what do we need, what are we going to try, and this was one of the first scripts we made. It works very well. My computer gets very much overheated if I put 100,000 codes in there at once. But yeah, that was also a learning curve.
Now, I was wondering how sure are you that the data that is exposed by API is not biased by not by accident, by purpose? That they do give you the right data, or that doesn't matter for the AI model in the end. It levels it out probably.
It's a very good question. The thing with the database that we're using right now is that the original company that we get the data from, they offer similar tools, and we are convinced that if they would influence us, they have to influence themselves because it's one-on-one the same information. They only use it in a different method. They use it for advertisement strategies. So, for instance, the cost per clicks on advertisements they can define with that. And we think that if there would be, at least my thought, if there would be a bias in there, then maybe like with all the different sets of variables and recombining them in different, yeah, we call them neurons, then that should level out. And perhaps even one single variable or one misunderstood parameter could not directly tackle the whole model.